number 1, we're in 2.5. This is basically distributing part 2 with a small side trip of an intro idea. So you might remember a few days back we had 8 properties that someday I'll make a quiz. So if you don't at all remember what those properties were or what they were about, if that's been memory wiped somehow, you should go back and check out the 2.3 video sometime again, or your notes from 2.3 or the book from 2.3, and try to remind yourself of reflexive symmetric transitive, or ST 1, 2, 3. Remember that. There were 2 commutative properties that involved moving the order of things. There were 2 associative properties that had to do with grouping parentheses of things. Distributing was the superstar of that day. Some of that homework had distributing. That'll be back in a second. But before we take a venture off into distributing, they're going to talk to you about a thing called the opposite. Some books, instead of the word opposite, will use the term additive inverse. So if you're asked to ever find the opposite of negative 5, that would just be positive 5. If you're ever asked to find the additive inverse of negative 5, that would still be positive 5. Another way that they'll sometimes ask this question, instead of using those words, they'll use the negative sign itself as a symbol, and then put negative 5 in parentheses. So if I ask the question this way, it's still positive 5. Okay? Whether I say the opposite of negative 5, the additive inverse of negative 5, or use this symbol to say opposite of negative 5, or additive inverse of negative 5. These all mean the same thing. They all mean just switch the sign. It was negative. Whether I use these words or this symbol, it just means switch the sign, go positive 5. So I could either say opposite of positive 5. I could say additive inverse of positive 5. I could stick a negative out in front of parentheses with a positive 5. But all of those answers would lead to negative 5. Because opposite, additive inverse, this sign, they all mean just switch the sign. If it was negative, go positive. If it was positive, go negative. That's a small item for today. The bigger issue for today is just distributing again. So when we distributed at first, this problem's not on your notes, but here's a recap of distributing. We get one number out in front of parentheses. There's adding or subtracting inside. And this number wanted to multiply both of them. It's like double multiplication. 4 times 3 can be 12 with an x. 4 times 2 is 8, but that didn't have an x. If this is a plus, go with the plus. If that had been a minus, go with the minus. I think on the day we did that, it was all distributing numbers. But as part of the lesson, I did a discussion on you can distribute a number, which will multiply all the numbers. You can distribute a sign, a negative sign, which would switch all the signs, and that's what connects us a little bit to why the opposite discussion appeared in the book in this section. This is the opposite, or the additive inverse of these. When you distribute a negative, it just switches all the signs. When we go venturing to the right, over here, we're going to distribute some negatives and some numbers at the same time. So that would do both things. If you think you have the hang of this from 2 lessons back, go ahead and pause the video, try the questions, see if you get the right answers. If you're not confident in doing that, just keep listening. But if you gain confidence, pause the video. The more you work on your own, and the less you spectate me, the more you're going to get out of this experience. So you want to try to maximize your work and your think time, and then make sure you're on the right track. But if you distribute a negative again, all that's going to do is change all the signs. So we're still going to get a 3x. We're still going to get a 2. But what this distributing of a negative is going to do, it's going to try to attack both of these. The 2 that had a minus will be a plus. The 3 that was positive without a symbol is now going to be negative. If you didn't yet, try the next one, pause me and do it. Again, don't change 4x, don't change 6, but the minus, because of this, will change to plus. The positivity here will change to negativity. So distributing a negative, just switch all the signs of what was in there. Step into the right. Okay, this negative is going to change all the signs, But the 2 is also going to multiply all these numbers. So 2 times 6 is a 12. 2 times 7 is a 14. This used to have an x, it still should. These were both positives, so we need them to both be negatives now, because this negative is going to switch all the signs. If you got that, try this one without me, and then check it after you're done. 3 wants to multiply both, so there's a 6, there's a 24. 6 needs to have an x, because the problem had an x. And then a change of sign of negative makes positive. A change of sign of another minus is going to make that be a plus, to link those together. For this, we're going to have to go 2 steps. Okay, so for this 3x plus 4, just leave it alone for a moment. This minus needs to go to work. The minus is going to switch all the signs of everything inside. So minus attaches to the x. The other minus is a plus, and the 6 is still there. And now we'll need to combine like terms. We had combining like terms a few days ago. This is called a term. Positive 3x is a term. Positive 4 is a term. A negative x is a term. Positive 6 is a term. What we're going to look to do is the add rules with the piece of the terms called the coefficients. The coefficients are the numbers in front. And you might remember, hope you remember, if you don't see a coefficient, there's always an invisible 1. So if we look at the xy stuff, there's a negative 1 wants to add with a positive 3. And the add rules tell us that when they're different signs, positive 3 versus negative 1, it's going to depend on the bigger, which is positive, and we subtract to get a positive 2x. Then look at the numbers. A positive 4, positive 6. If they're both positive, keep it positive, just add them, that makes a 10, and we're good on that. If there's ever parentheses with a negative in front, the negative's got to switch all the signs. If there's parentheses with nothing in front, you do literally nothing. So this set of parentheses on this next problem are just there for distraction or decoration or whatever you want to call it. For 6x plus 7, we can drop the parentheses when there's nothing in front of them there, just an empty space. When there's parentheses with a minus, we need to do a switcheroo. So with 3x and 4, the 4 was minus, now it's plus. This 3 was positive, now it's negative. And then it's going to be time for us to combine some like terms. In the world of the x's, a positive 6 versus a negative 3, the positive wins by 3, subtract them. In the world of numbers, positive 7, positive 4 join up, and that's positive 11. Next question, about the same thing. We're going to want to distribute, so 6x minus 10, once the 2 gets both of them. The minus is going to change both of those to be both negatives. 4's got to jump on both numbers to get 8x and 12. And then combine like terms. For the x's, there's an 8 that's negative. The sign in front of the coefficient remains attached to it. So 8 is negative, 6 is positive. The negatives win that battle by 2. When they're different, we subtract them. And then in the world of numbers, there's negative 10, negative 12. Those are both negative, so keep it negative and just put them together. 10 and 12 added together is 22. The last little bit of homework will ask you to evaluate expressions. What I wouldn't do on these, I don't think, is do all the distributing and stuff. I don't think I would do the distribute. I think what I would do on this personally would be to take the numbers and put them in and just do the math that presents itself. If you wanted to distribute, it's not wrong. But on a question like this, to distribute this, combine it with that, redistribute the 2, combine again, like that's a lot of work. I don't think that's probably the way to go for most people. I think you're better to just put the numbers in and do the math that presents itself. On this one, if you're wondering what these are, those are just parentheses. Sometimes when there's parentheses inside other parentheses, which are called nested parentheses, sometimes the book, instead of doing parentheses each time in the normal way, they'll do different types of parentheses. It's just easier to see. This starts here and ends there. This full thing's a group because they have the same type of symbols. That's a different group because they have the same type of symbols. But what I would do on these, I would suggest just take the numbers and plug them in. So the -2, if you insert that there, the negative and the 2 are traveling together. A is both negative and 2. So when you put that in for A, the negative and the 2 both go in for A. A few lessons ago, 2.2, the exponent lesson, taught us that negatives to an even power are positive. And then we want to do 2 squared is 4. So this right here would get us a 4. If we put in the B to be 6, nothing really to change there with B being 6. So the parentheses here should contain 4 plus 6, and that's weighted. That negative in front of the parentheses is just going to change the sign later. We would do the parentheses first. 4 plus 6 is 10. And then the negative finally does its job. Grand total, -10. For this one, same thing. Put the 5 in. Okay, 5's got to go here. 5's got to go there. And then you want to try to work with parentheses stuff from the inside out. So we want to attack here first. 5 minus 2 is 3. Inside this group of parentheses, we have a multiplication to do over here also. So parentheses are first. There's a multiplication here. There's a multiplication there. I'll save add for later because parentheses are 1 on the order of operations. Exponents are 2. Multiply, divide was tied for third. Add, subtract, tied for last. But we have 3 times 3, that's a 9. 4 times 5, that's a 20. The plus would still be there. 20 plus 9 is 29. And that's the full value of this brackety thing is 29. 4 adding 2 and multiplying is still there. So we want to multiply before we add. 2 times 29 is 58. 58 adds 4, grand total would be 62. Homework that goes from this is from page 70 something. No, 60, page 69 is where it starts, and then it spills into page 70. We're working 1 to 14. 1 to 14 is a lot like this. Distribute some things, combine some like terms. Then that'll take us to 10. 11 is starts some problems more like this. Put the numbers in and do the math that presents itself. That'll take you 11 to 14. 17 is that same type of problem. 18, same type of problem. 34 is kind of like a giant version of this. And just what I ask everybody, just try 34. You might get it right, you might not get it right. If you don't get it right, you don't have to lose sleep over it. But if you get 34 right, you really dominated this lesson. It's like a supersized version of this stuff. So we're doing all the 1 to 14, then skip down to 17, 18. 17, 18 are about sized like this. And then 34 is just like a big monster. So if you need any help, email me. We'll do something on Zoom sometime.